Hi everyone, welcome to KCD Bangalore 2022. I'm Shweta working at VMware, and in this session, I'm going to talk about new test framework for Kubernetes. Testing is a critical part of the software development lifecycle, which enables more confident delivery of the product to the end customers. So in recent time, we have seen large number of platform solutions are built on top of Kubernetes. So how these products are getting tested before reaching to end customers. So quality assurance team might be doing manual or automated tests or maybe both. But when it comes to automated, it becomes very tricky because either one can use the existing Kubernetes testing framework or write the test from scratch. And if you have a tight deadline, then writing the test from the scratch wouldn't be a good idea. So now the question is, why don't we use the existing Kubernetes test framework? So there are a couple of challenges with Kubernetes test framework. So when I say Kubernetes test framework, it resides under github.com/kubernetes/test. So it's a framework which has grown organically with Kubernetes, and it's harder to reuse. If you are writing a component for Kubernetes, and if you want to do testing, then chances are to rebuild the test from scratch. And moreover, if you want to reuse Kubernetes test framework on your own components, it's very difficult to manage as it vendors all the dependent packages. And I don't think people would prefer to keep all the vendoring dependencies as it's very difficult to maintain. Now you might be thinking, don't we have any other frameworks available in the market? Yes, we have several testing frameworks available already as open source projects. Let's see what are those. So I have listed down some of the frameworks here. One of them is kubetest2. Kubetest2 is used to orchestrate the steps necessary to run an end-to-end test against a cluster in CI or locally. So it's a localized framework to launch cluster and testers. It does not contain any test or any test framework. Sonobuoy is a diagnostic tool which makes it easier to understand the state of a Kubernetes cluster by running a set of plugins. It includes a Kubernetes conformance test also. So it's a customizable, extendable way to generate informative reports about your cluster. Ginkgo framework is mainly used for behavioral driven development and used for unit testing, integration testing, performance testing, etc. The Kubernetes test framework is based on Ginkgo framework. So all these listed frameworks are dedicatedly focusing on one thing. So either cluster related test or just a framework which describes the test like Ginkgo or to get some reports like cluster state. So these challenges led us to have a new framework which should easy to reuse, which should be a portable one, avoid direct dependencies on upstream Kubernetes packages, remove the dependencies on non-standard Go-based test packages. Now the question is, are we trying to replace upstream Kubernetes test framework which is already exists? The answer to this is no or never. So what we are trying to do is to come up with a framework which makes easy to do end-to-end testing so that component developers don't reinvent the wheel again and again. So this brings us here to showcase a more generic end-to-end testing framework called e2e framework. It comes under the Kubernetes 6 testing umbrella, and it's a great framework to overcome many hurdles. It completely built using Go testing, and it has ability to integrate and leverage existing test components. Let's see what are the features and what are there in end-to-end test framework. So in e2e framework, we have two frameworks. So one is test harness framework and another one is client helper framework. So test harness is the one you can use to design the test. So basically it helps you to design the life cycle of a test. When I say life cycle, it includes from setting up an environment till tearing down the resources. For example, if you want to test some features on cluster, the prerequisite would be setting up the cluster, right? And run the test on top of it. Then bringing down the resources created during the test execution process. And finally, tear down the cluster. So test harness mainly helps you to express test as a series of customizable steps, and you can control the entire execution lifecycle. Now let's see why client helper framework is for. You people might have noticed the client spelling. So it's not starting with C, it starts with K. So it's because we just wanted to make it as a helper framework for Kubernetes related stuff. So it is called as a client helper framework. So client is a Go package, which is intended to provide abstract the complexities of project Kubernetes client Go. And it provides helper functionalities to make it dead simple to interact with clusters and the API servers. One good thing about end-to-end framework is it's not necessary to use both the framework. So based on your requirement, you can choose either test harness or client helper or both. So if you don't have any dependency on cluster, then you can just use the test harness framework. Now we'll see what are the features supported in this framework. After that, we'll walk you through the examples. So this framework provides a uniform API to work with typed and untyped Kubernetes API objects by having simple client, which includes Kubernetes resources, CRUD operations, and control operations. So you can easily create, update, or delete Kubernetes resources. It even provides a type which allows test writers to install third-party tools. So we have integration with Helm charts. So there is a decoder functionality which provides a utility for creating Kubernetes resources or objects from inputs like YAML files or JSON files. So this is very useful feature which reduces the verbosity and complexity of defining many types. And understanding which packages to import may add a burden to test developers. So this feature manages resources as YAML or JSON, and it has the benefits in maintainability. This framework even provides you the creation of client cluster for your test. So we have a supported predefined function to create a client cluster. Context propagation, this is one of the important feature in this framework. This is very useful to propagate the values to the next steps or phase of a test. So when we see example, I'll explain you how to use the context propagation. The framework also supports parallel test execution using the flag -- parallel. This executes the series of test features in parallel. So based on your requirement, you can choose to run test serially or parallelly. Even one can filter the features using predefined flag sets. So these are the available predefined flags. So for example, if you want to run a particular feature, then just provide -- feature equal to the feature name. It will just run those features. If you want to skip some of the assessment, you can provide -- skip assessment equal to assessment name. It will skip those assessments. If I'm not wrong, in Ginkgo V1, these filters are not available to use while running your test externally. So mostly they are enhancing these features on Ginkgo version 2. Okay, so let me give you the quick overview of end-to-end framework code base. Let me open the VS Code. So this is the folder structure of e2e framework. So if you want to go through the design doc, you can refer this folder. Package folder contains the implementation of test harness, and client folder contains the implementation of Kubernetes helper functions. Let's go through the package. The environment object is the heart of the framework, which allows developers to define and implement features to be tested. This contains all the methods to define the life cycle of a test, like setup, before each test, before each feature, after each feature, finish, etc. So if you see this setup, it registers an environment function that are executed once prior to the environment being ready. After each feature, it registers the step functions which are executed after each feature. Finish, you can register the functions which are executed at the end of the test suite. Let me show you the command line flags supported by e2e framework. So these are the command line flags supported by this framework. So if you have your cluster already up and running, by using --kube flag, you can provide the kubeconfig file path. So client package, to initiate a connection with the API server, you can use one of this function. So if you know already the kubeconfig path, you can use the new function. If you are using in-cluster config, you can use new in-cluster method. If you want to set the Kubernetes context, you can use the new with context name. So under k8s resources.go, this is a file where all the CRUD operations being defined. Update, delete, create, and list, etc. Now we'll see how to use this framework efficiently by examples. Let's see simple test function. So this package shows how the test framework can be used directly in test functions without setting up a test suite. So I'll explain you what is a test suite in a while. So whenever you write the test function, first thing you have to do is define an environment object. So here using new with config and providing empty configuration, this environment object is being defined. This is how the feature has to be defined. So this is the feature name. It has a label, type, and symbol. This is optional. And setup. So this is the actual test which will run when we run go test. And before running this test cases, first it will run the setup. And using the environment config, you can invoke this feature. Okay, let's see the suites. So what is a test suite? So test suite is a method which is defined in a package level. So one can define setting up the prerequisite or cleaning up the resources in this suites. So in our files, main_test.go act as a test suites. So here we define test main. So what is test main? In Go testing, test main is a function which will become an entry point for all the tests in a package. So we have taken advantage of this feature of Go testing in this project to define a suite. So for this package, the main test will be the test suite. So entry point will be here. Let me explain context propagation also in the same example. So if you see here, we have defined a context value with the using new with context. So let's see how this context value being propagated to other test files. So if you see hello_test.go, this is how the context value being retrieved. So context propagation helps you to pass on the information or any details of previous test to the other stages. Let's see filter test.go. As I said, we have lots of filters available for skipping the features or selecting the features for running. So as I said, there are lots of filters available for skipping the features or selecting the features. Let's see the example here. So what it does in the code itself, it just selects the assessment using the regular expression. So if you see here with assessment regular expression add hyphen star, so what it does is it will just run the assessment which has the prefix add. So basically it will skip this repeat message assessment. Feature set test.go. This demonstrate how to um, run multiple features in a test. So we can list down the features list here, F1, F2, F3, whatever it is. Let's see how to use client package. So in the main test.go, in the setup, as a prerequisite, we have created a kind cluster. Even here we have used context propagation to store the cluster information, and the same context being used here to retrieve the cluster configuration, and using that we are just destroying the cluster. So once this setup is done, then it will run the actual test which is written under k8s underscore test.go. So this feature, what it does is it just lists down the pods under namespace kube system. So to access client helper functions, first thing is you have to do is create an object of client using configuration.new client. So after that, you can just access the CRUD operations or CRUD methods defined in the client helper functions. Let's see Decoder. So if you see here, we have a YAML files and even JSON files. So in the decoder test.go, so you can see here using decode any, you can decode any single file. Using decode all files, you can decode all the files under this test data folder, and you can just get the objects list, and you can loop it, and you can convert it to the actual Kubernetes object. So if you want to know more about how to use this decoder, you can just go to this examples decoder. There is a readme file which explains how to use decoder in different way. Okay. Let's see third-party integration. As I said, we have Helm integration as well. So if you see here, what we are doing is here this test feature demonstrates how repo-based Helm chart workflow works. So here we are running a repo nginx table, and once it is added, we are updating this repository. Then it installs the nginx Helm chart. And this next step, we are just waiting for this deployment to up and running. Once it is done, we are tearing down or removing the installed repo. Okay, wait for resources. So what happens whenever you deploy a Kubernetes object, it will take some time to up and running. So if you have to wait, or if you want to keep on polling the status of that particular pod or resources, you can use wait.for function. So if you see here, once the deployment has been created, here in this test case, we are waiting till this deployment is 50% available. So here the condition which has been added. So this is done using wait condition functionality. Parallel features. So if you want to run the features parallelly, you can define feature here. So for example, here in this test case, feature 1, feature 2 are defined, and we have used test in parallel method to run this feature 1 and feature 2 parallelly. Okay, I hope this might have helped you to get some idea how to use E2E framework on your projects. Let's go back to slides. Happy to see that already community have started using E2E framework in their projects. Gitbots, Sonoboy, k8s service validator are some of the examples. So if you see Gitbot, they have used e2e framework for refactoring integration tests to simplify the setup and definition of test cases. Even k8s service validator, they have used e2e framework for designing their test. Let's see the roadmap. So these are some of the features in a pipeline which we are planning to add in e2e framework. So like kubectl helper APIs, we want to implement clusterctl APIs helper function. Even there is already a draft design on Kubernetes constructor APIs. So this design proposes a functional approach where a developer would use function and method calls to automate the creation of Kubernetes object graphs. So when I say Kubernetes object graph, for example, if you consider deployment a YAML file, in the deployment, there will be different section, right? Like metadata, spec, container section, or the prop section. So this would be for to define these objects, Kubernetes constructor APIs will be helpful. Special thanks to Vladimir Vivian for designing such an awesome projects, which makes developer life hassle-free. Thanks, Vladimir. Let us join our hands together in moving this forward by contributing, reviewing, and giving suggestion and feedback. Thanks for giving your precious time and listening to us patiently. Feel free to reach us on Slack or Twitter handle. Stay tuned for the rest of the sessions. Thank you.